In this example, we will show you how to use the heat flux equation that has been modeling using the numerical method in solving the heat flux magnitude for this 9 point. And also, by using these two equations, we should be able to find the magnitude as well as the direction for the heat flux. So first of all, let's say the plate is given the size 40 times 40 cm and the coefficient K is given by 0.49 as is made by the aluminium. So we start to find the heat flux in x direction for the first point. So this is our T11. Okay, so this is our heat flux at x direction for T11. So we name it as Qx11. So we apply the formula here, Qx11. Okay, so 1 indicate our I equal to 1 and J equal to 1. So by substituting inside this formula, you get 2, 1 and 1 and 0, 1. So the temperature 2, 1 is 33.3 and the temperature 0, 1 is 75 degrees Celsius here. So you substitute inside the equation and delta x. So what is the distance here? So you have 1, 2, 3, 4, 5 points. Okay, and making the distance separate by 4. 1, 2, 3, 4. So the distance here is delta x. So the length here is 4 delta x. So since it's given that the dimension is 40 cm, so we know that 4 delta x is equal to 40. So from here we know the delta x is 10. So with that we can substitute inside the formula, and the k is just a constant, we can substitute. And with that you obtain the Q to be positive. So if this is positive, it means that it's in x direction. If you obtain negative, it should be opposite. So if you obtain positive, it's in x direction. So if you obtain something in negative, it should be in negative direction for the x. So with that, we have successfully computed the Qx magnitude, which is 1.022, and is positive moving to the right hand side. Okay, this is our x direction. Next, we are going to find the heat flux in y direction. Then we are going to use the second equation here. So at this point is 1, 1. So we put it 1, 1. As you should know, your I is 1, your J is 1 as well. So when we substitute this formula, you obtain 1, 2. And here you obtain 1, 0. So the temperature 1, 2 is at here, 63.21. So you can substitute into this. Okay, T12 is 63.21. How about T10 is over here, is 0 degrees Celsius. So you can substitute inside here. So how to find the delta y? So you see the distance here is delta y between 2 points. So how many delta y you have here? So if you compute like this, you found that the total length in y-axis is 4 delta y. So the total length here is 4 delta y, and based on the given dimension is equal to 40. So same thing, so your delta y is equal to 10 in this case. So you substitute inside here, then you compute and you get negative in this case. So since you know positive y is moving upward, then negative y should be moving downward. So with that, you know that the direction for the heat flux in y direction is moving downward. So we obtain this. Next, we are going to find the resultant heat flux by using this formula. So you substitute this inside the formula, square it, and then substitute this and square it. And these two information can be substituted inside this formula to find the direction. So when you do the calculation, you should be able to obtain this answer. So the angle here is negative 56 degrees Celsius. So what does this mean? So if positive, it should be counterclockwise. We refer to the 0 degrees Celsius and 0 degree here. So counterclockwise is in this direction. So this is positive angle. So if you have negative angle, it will move in clockwise direction. So this is your negative angle. So with that, we can compute the magnitude of the heat flux and also the angle here. It should be equal to 56 degrees. So I have shown you how to find the heat flux magnitude as well as the direction. So the magnitude is indicated by the length. So you can see the length, okay, the larger length, it means the magnitude is larger as well, right? And the direction is given, okay, so you know that this direction, the angle is around 56 degrees. So you can repeat the same procedure to find the direction for the rest.